So many possibilities.
My mind is racing.
If we're gonna use this thing, which I'm not even sure we should, we need to keep...
Let me become the best beer pong player. This is me. And I'm kinda bad at beer pong. But I can build stuff. So let me explain how I imagine it. Instead of throwing the ball, you let it just go. And howsoever his flying course changing to something like this. Our invention that let everybody become the best beer pong player ever clearly needs the ability to change the direction of the movement. The ball enters vertically and leaves the device in an angle of 85 degrees. Because of the complexity of the parts, our choice of manufacturing will be 3D printing. The difference between a normal printer and a 3D printer is that in 3D printer got an axis more and prints with plastic. For an easier print, we split up the deflection tube into 3 parts with upgraded mount for later connection. An added benefit of splitting the parts is that you can easily change the launch angle by just swapping out the last piece. Now we need to secure the tube to a plate. To connect the tube with the plate, I will use screw connections, so I can unscrew and screw up every time I want without that the material fatigue. To make this work, we insert threads to the plastic parts. The plate will also get a placeholder for batteries and electronics. With the help of a soldering iron, the threaded inserts are heated until the plastic begins to melt, and the inserts can be pushed easily. With the assembled part, the ball gets a new trajectory. However, the force of gravity is not enough to make the ball fly far, so you need a way to accelerate the ball. The choice here are DC motors with rubbing wheels. The printed parts got a placeholder for the DC motor to slide in. They get fixed in place with adjusting screw to determine their height. For higher friction between the ball and the wheels needs to get a rubber cover. As a power source for the motors and the electronics, I use 4 AA batteries with 1.5 volts each. Connected in series, this gives 6 volt. From now on, I will call this invention box. For easier pronunciation, if the batteries are directly connected to the DC motors, the ball always flies the same distance. A voltage regulator is required to control how far the ball flies. With higher voltage, the wheels also turn faster and the ball is accelerated further. The same works with lower voltage. To control the aim of the box, you need to move it for horizontal alignment. The vertical is done via the voltage regulator. One way to regulate the voltage is via microcontroller. Apart from its small size, using a small computer for such a simple task doesn't seem right. A very simple, small and cheap solution would be to use a potentiometer. The only downside of this is that his efficiency is very poor. Pulse width modulation is very cheap and efficient. To explain how PWM works, let's compare it to a potentiometer. A potentiometer achieves its regulation by changing the magnitude of the resistor. This leads to dissipation where energy is lost through the heat of the resistor. PWM regulates the voltage by periodically stopping it for a specific time. As an example, when this specific time increases, the voltage will decrease. Without a resistor there are no dissipation and so it's more efficient. Hence, PWM will be the choice for our box. To test the electronics, I connected all the components on a breadboard. The direct current to PWM signal conversion is done by this chip, the 555 timer. To check the voltage, I use a multimeter. The 3 batteries should deliver about 4.5 volts. To check the PWM signal, I turn the knob that is supposed to change the voltage level. And that's exactly what happened. Finally, to connect the PWM signal to the motors, I use a dual DC motor driver controller board.
stop.